Okay, let's have a look at question 4, exercise 10J. That's the function. Show that f is decreasing for all x values in its domain. Well, let's put it in this form, okay, to save us using the quotient rule. And we'll take the derivative, so it's the first times the derivative of the second. That one comes from the derivative of x, the inner function, plus the second times the derivative of the first. That one comes from that one. We tidy this up. We've got minus x over x minus 3 squared plus 1 over x minus 3. Now we'll get a common denominator here. We're going to use x minus 3 squared, so we've got to multiply the top and bottom by x minus 3. And that became, the x's cancel, and we've got minus 3 over x minus 3 squared. Now the question was, show that it's decreasing. Well, therefore the derivative is always negative, because for whatever value x we put in here, it's squared. So the derivative is always negative. Therefore, the function is decreasing for all x values in its domain. Okay. B, show that f has no points of inflection. Okay, so we've rewritten the first derivative. That came from here. We're going to rewrite this. It's simple enough. We put it like this. We take the derivative of this. That's already the first derivative, so that'll be the second. It's the first, well, it's minus 3 times that. Well, it's quite simple, really. Okay, so it's just minus 2x to the minus 3, x minus 3 to the minus 3 power. And that became 6 over x minus 3 cubed. Okay, for the second derivative, is equal to 0, okay, because that's where an inflection point would be. We ended up with this have to be 0. Well, that has to be 0 for that to be 0. Now, we're told that x cannot equal 3, and there's no other situation for it to be 0, so therefore the original function has no points of inflection.